Morning. Right, moving on from speed, distance and time from last week. This week we're going to draw and interpret distance time graphs and calculate average speed from a distance time graph. So, as per usual, I want you to put the heading down and the learning objective, dates in Welsh, underline. So click pause. When you're ready to move on, hit play. Okay, so we move on to our starter. So hit pause. When you're ready, hit play again. I have a few more questions, so we'll go on to the next page before we go over the answers for this one. There we go. So complete all 7 questions, hit pause. When you're ready, we're going to go over all 7 questions. Okay, so we're going to go over all the questions here. Over question 1, 3/7 of 35. I don't like writing 3/7 in that fashion. I prefer to write it as a proper fraction, so 3 over 7. Of means times. Now you can simply work out 35 times 3 and then divide it by 7, which is fine. I think that's a common way of doing it. Or, as we set it out like this, you can see 7 goes into itself 1 time, and 7 goes into 35 5 times. So I can do 3 times 5 is 15. Okay, and it's over 1, but anything divided by 1 is itself. So like we were saying, you could have done 35 times 3 equals 105, and then do 105 divided by 7. Okay. Next, 14 out of 20 as a percentage. So 14 out of 20, so it'll be 14 over 20. And as a percentage means it's out of 100. So 100 is our whole. So same sort of thing, you can do 14 times 100 and divide by 20, or you could say 20 goes into itself 1 time and 20 goes into 100 5 times, and do 5 times 14. 14 times 5. So 4 times 5 is 20, 0 carry 2, 5 times 1 is 5, plus the 2 is 70. So that's given us 70%. Question 3. Which is the best value for money? 300 mil for £1.20 or 400 mil for £1.40? Now, you can't compare unless you make them the same. Yeah, so we've got to make them the same. So you can only compare like for like. 300 mils for £1.20 or 400 mil. So if I make them 100 mil, so that means that this means that 100 mil will cost £1.20 divided by 3, because to get 100 mil I divide by 3. So £1.20 divided by, write it as a fraction, 3 gives me 0.40 or 40 pence. Here, to get 100 mil, I divide by 4. So, similarly, I do 100 mil costs £1.40 divided by 4. Write it as a fraction. Okay, and that's going to be 0.4 into 14 gives me 3. Carry 2. And 4 into 20 is 5. So 35 pence will be 40 pence. So best value for money, remember we have to answer the question, is the 400 ml bottle. There you go, that's your best value for money. How long does the 1117 from Warrington take to get to Nottingham? So first we've got to find, there's Warrington. And we're going all the way to Nottingham. So the train we're looking for is this one, 11:17, and it arrives in Nottingham at 13:32. So we're looking for how much time it's going to take to get from Warrington to Nottingham. So if we start at 11:17, I'm going to go up to 1200 hours. How many minutes is that? Okay. 43. So that's 43 minutes. I'm going to go from 12 till 1300 hours, 1 p.m. That's 1 hour. And then from 1300 to 1332 is 32 minutes. If I add those together, I'll get 2 hours. Take away 17 from there, it leaves me with 15 minutes. Good. So mark in green pen, and remember, if you have got anything wrong, write down the complete solution. Okay, not just the answer, write down the workings. And moving on. So the multiplier for a 30% increase then. So it's going to increase by 30%. Yep, 30% is the same as 0.3. So that's 0.3 as a decimal. But if it's increasing, it's going from 100 to 130. So we've got 130%. Oops. And that's going to be as a decimal 1.3. So that's our multiplier. Next, use the conversion graph to change 60 miles into kilometers. So we're looking for 60 miles. That's miles on the y-axis. So if we take that across, we have to draw a line across. Oops. So we draw a line across until it meets the line, then we drop it down. And it's just to the side there. So that's 90, that's 95. So it's going to be about 96 kilometers. Okay, so 96 kilometers. What will I take for that? I think I'll take anything from 95 to 97. So 95 to 97 is acceptable. Okay, and finally, what shape is this net of? So there's our net there. What's the shape? Well, the base, when you fold it up, is going to be a square. So it'll be square based. And when you fold it up, it's going to give you a pyramid. So square based pyramid. Okay, good. As before, write down the corrections if you didn't get it wrong. Otherwise, tick in green. And remember, corrections in green as well. Good. Moving on. Oh, I've got a couple of questions here for you. Okay, so hit pause and attempt these. When you're ready, hit play again. Okay, so hopefully you managed to convert these. If we start with the first one, 1 hour 30 minutes is the same as, whoops, don't want to do that just yet. So 1 hour 30 minutes is equal to 1 hour. Now 30 minutes is 30 out of how many minutes in an hour? 60. So 30 over 60. Now we've got a 0 on the bottom and 0 on top. So I've got 1 and 3 out of 6, which is the same thing as 1.5. And as a decimal then, I can express that as 1.5 hours. So we look at the hours, and then the minutes, we take it out of 60 because it's part of an hour. So same again, 2 hours and 15, a part of 60. Okay, now I know that 15 goes into itself once, and 15 goes into 60 4 times. So that's 2 1/4. Quarter is 0.25, so that'll be 2.25 hours. On to number 3, same thing, so it's 2 hours and then 36 minutes, so 36 divided by 60. So because it's 36 out of 36 minutes in an hour. Now I'm looking for something that goes into the top and bottom, same number, but the biggest number. This one I can think of is 12. Hopefully you thought of that. 12 goes into 36 3 times, and then 12 goes into 60 5 times. So that leaves me with 2 3/5. Now 3/5 is 0.6, so it'll be 2.6 hours. And on this one, we got 4 hours and 20 minutes, so 20 out of 60. You can see a 0 on the bottom and a 0 on the top, so they can cancel each other out. 2 out of 6 is the same thing as 1/3, so that's equal to 4 1/3. As a decimal, a third is recurring, so it's 4.3333 onwards. So you can write it like that, or to make it easier, I could do 4.3 with a dot above the 3 there, and that dot is telling me that it's recurring, so the 3 recurs forever. Reciprocal means 1 over. Okay, so it's 1 over, so basically we're flipping the fraction. So reciprocal of 7 is given by 1 over 7. That's it, as simple as that. Same thing here with reciprocal of 1/4. We flip it, it's 4 over 1, which is just 4. What we're saying though is 1 over the quarter, 1 over 4, which means 1 times, you can flip this if we're multiplying by if we're dividing by a fraction, 4 over 1, which is just 4. Okay, so we just flip that over, 1 over 4, reciprocal is 4 over 1, which is just 4. Reciprocal of -3 is 1 over -3. And because we know we can flip it now, reciprocal of -2/5 is -5 over 2. When you get a fraction, you can just flip it like that. Okay, good. So what I want you to do is to go back into the assignment, and there are 2 worksheets, which if you can print them off, that'd be great. If you can't, then you just carry on with the PowerPoint. But if you can print them off and attempt the questions, then we're going to go through the questions in just a minute. Okay, so those 2 sheets, see if you can print them off. Good. One of the sheets actually looks very much like this, with some questions. So if you can print that sheet off, then you'll be, and then answer the questions. If not, just answer the questions in your book now. Click pause, answer the questions, and then we're going to go through them in just a minute. Okay, so hit pause. When you're ready, hit play again. Okay, let's do some solutions then. Time of leaving Alford. So, well, let's have a look at the graph first off. So the graph shows time against distance, and the car is traveling, or the passengers are traveling from Alford to Catford, Alford through Bedford, and then back to Alford. And in between, they have some flat spaces there. Okay. So if we look at the questions then, what time did they leave Alford? So we start here at 1000 hours. So we haven't been given if that's AM or PM, so we're just going to write 10 there. Okay, what time did they arrive in Bedford? So they drove to Bedford, and what's Bedford here? Now 10 to 11, I've got 1, 2, 3, 4. 4 spaces in between. So 1 hour, 60 minutes divided by 4 gives me 15. So each square is going to be 15, 15, 30, 45, and then back to 60 again. So if they arrive here, that's halfway between 10 and 11, so that's going to be 10:30. They've arrived. Distance from Alford to Catford. Alford is here, Catford's up here, so the distance is 45 kilometers. So we've got 45 kilometers. Next question, how long at Catford? So how long did they spend at Catford? So when they got to Catford here, if you look at the time they got to Catford, is 1100 hours. They stayed for 2 squares, 15 and 15, so 30 minutes. So we can say they spent 30 minutes at Catford. Okay. Next question, what is the fastest part of the journey? Okay. Now how can we tell that just by looking at the graph? Okay. Is it that part? Is it that part? Or is it that part there? Because the flat bits are where they're not traveling. Okay, they're just spending time. So it's got to be one of these slopes. So one of these slopes is going to tell us which part of the journey is the fastest. And it's got to be the steepest slope is going to tell us. And when I look at it, the steepest slope is from Bedford to Catford. So that's our fastest part of the journey, Bedford to Catford. You can also use your speed equals distance over time and work it out. So from Bedford to Catford, you could work out the distance, 25, divided by the time taking, 15 minutes, or as part of an hour, 0.25. Slowest part of the journey. So if the fastest part is the steepest, the slowest part is the least steep, and that's Alford to Bedford. So Alford to Bedford. Average speed from Alford to Catford. So Alford to Catford, well, let's see if I can remember first. Speed is equal to distance over time from last time. The distance from Alford to Catford is 45 kilometers, so that's going to be 45. And the time it took to get to Catford, arrive there, starts at 1000 hours at Alford, arrives there at 1100, so that's 1 hour. So 45 divided by 1, which is equal to 45 kilometers per hour. And finally, the average speed on the return journey, so going from Catford back to Alford, again we've got speed equals distance over time, so we've got to write that there. Speed equals d over t. The distance is the same, 45 kilometers, and but the time then, this time, they started here, 2 squares across, so started at 11:30 and finished at 1200 hours. So they took half an hour. So in half an hour, they managed to drive 45 kilometers. Okay, so in half an hour, they managed to travel 45. Now, you can do that on your calculator if you would like. 45 divided by half, or 0.5. Or, you could use the reciprocal technique, 45 times. We flip this over. We're changing it from a division to a multiplication, so times 2 over 1, which would give us 90 kilometers per hour. Oops. There we go. Okay, so 90 kilometers per hour. So as you can see, if they do 45 kilometers in half an hour, then you're going to have to double it for the full hour, so 90 kilometers per hour. Okay, good. So mark in green. Make sure you write any corrections that you need to in full. Okay, moving on to the next graph. So as before, there's a sheet attached to your assignment. travel graphs 2. If you can print this off and attempt the questions on that sheet, it just helps you so you can work it out. If you can't print the sheet off, it's not a problem. Just carry on working on this page. Hit pause, attempt the questions. When you're ready to go over them, hit play again. Good. Right then, moving on. Question 1, or question A even. How long do they spend at Big B? So this time, our graph shows distance against time, and you travel from Air B through Big B to Cat B, and we've got a time here in hours. Now, in between each hour, we've got 1, 2, 3, 4 squares. So if we say 1 hour divided by 4, 1, 2, 3, 4. That's the same as before. So 15 minutes each square. So how long do they spend at Big B? At Big B they arrive there. That's 8:45, and we've got 15, 30, 45. So we spend 45 minutes at Big B. So you can write 45 minutes there. What time did they leave Big B? So there's Big B. They left Big B there, and that's at 9:30. Again, we haven't been told if it's AM or PM, so you can write 9:30. How far is it from Big B to Cat B? So there's Big B, and to get to Cat B, you've travelled 8 miles and you travelled 20 miles. So 20 take away 8 gives us the distance from Big B to Cat B, and that would be 12. So we have 20 minus 8 equals 12 miles. Miles this time. Okay, what's the fastest part of the journey and why? As we were looking at it before, we said that the fastest part would give us the steepest gradient. So the gradient is the steepest. So it's either that part, here they've stopped, that part, stopping again, or that part. And just by looking I can tell that from Cat B to Air B, it's going to be the fastest part. So Cat B to Air B, I need to write that down there. And it's the steepest gradient. And the average speed from Big B to Cat B. So from Big B to Cat B, the average speed. Again, we know speed is equal to distance over time. So we're going from Big B to Cat B. The distance, we work that out as 12. And the time taken is from Big B to Cat B, Big B to Cat B. 15 and 15 is 30 minutes. Now 30 minutes is half an hour, so you can do 12 over a half. So you can do 12 divided by 0.5, or remember what we said, you can do 12 times, flip the fraction, so we turn it from division to multiplication, 2 over 1, and that's 24 miles per hour. Okay, similar sort of thing. Let's do the average speed on the return journey. So on the return journey, you're going from Cat B and go directly to Air B. So write our formula as usual. Speed equals distance over time. And then we work this out then. So distance traveled is 20 miles. It's 20, and the time taken, we divide by time taken. So they set off at 11:30, got there at 1200, so 30 minutes. Again, 30 minutes is half an hour, so 1 over 2. And so that's going to be 20 times 2 over 1, which is 40 mph. That's a 40 mph. Good. And the average speed for the whole journey then. So we started at Air B, travelled to Cat B, 20 miles, and then from Cat B travelled back. So that's a total distance of 20 and 20 is 40 miles. So let's write that down. S is equal to d over t equals 40 over, and now the time taken to go from Air B and then get back to Air B. 1 hour, 2 hours, 3 hours, 4 hours. So that's 40 over 4, which is 10 miles per hour. As before, tick your correct answers. If you got anything wrong, write down the full solutions, okay? And if you divide it by a half and you used 0.5, you use your calculator, it will pay you to actually write this down, write the solution, so you can see how we flip the fraction over and turn it into a multiplication. So it's something you can do when you don't have a calculator. Okay, good. Okay, with this graph, again, this graph is available in your assignment sheet, so you can print it off and then complete it by drawing the rest of the graph. Okay, if you haven't got the ability to print it off, then you need to draw this diagram in your book and then complete it. When you're ready to go through the answers, so click pause now. When you've completed it and you're ready to go through the answers, click play again. Okay, when we look at this, we got a journey going from Watton to Burton. Distance against time is our graph. And to go from Watton to Burton, you travel through Cadby. So it tells us that the car arrived in, so they've shown the part. So it traveled from at 900 hours, arrived at Cadby, and then spent 2 squares there. Now we don't know how many minutes each square is because we haven't worked it out yet. If we look from 900 to 1000, we've got 1, 2, 3, 4, 5 squares. So that's going to be 60 minutes. We can write it here, 60. Oops. So we go 60 divided by 5 squares. That means each square has 12 minutes, counts for 12 minutes. Okay, so the car arrived in Burton at 10:30. So it leaves Cadby, travels to Burton. 10:30 is halfway in between 10 and 11. And that's there. So it arrives there. And then it stops for 18 minutes. Now I know each square is 12, but that's halfway between. So that's going to be 6. So if you can write that down there, that's going to be 6 minutes there. And then this is going to be 12. 6 add 12 gives me 18. So I can say that I can draw my line from there to that box there. That's my 18 minutes, 6 add 12. And then it returns to Watton at an average speed of 100 kilometers per hour. Okay, so it takes 1 hour to do the journey, and it's starting here. It's going to be 12, 24, 36, 48 minutes. So 10:48, and it takes an hour to do at a speed of 100 kilometers. It's going to travel 100 miles. So the 100 miles is going to be done in 1 hour. So 1 hour from now, I can mark it out. It's going to be from 10:48 to 11:48. So it's going to arrive here. So I can draw my line from here right down to here. And that's my completed travel graph for the journey. Okay, good. So now what I want you to do is to attempt some questions for me. And I'll put the questions on here. And your questions for today, exercise 4.3. These are attached as well to the assignment. 81, 82 and 83, page 83, go up to number 12. Okay, good. Off you go, and good luck.